So this is 1.5 for MAC 1105 College Algebra. I'm Jorge Gavillan, and so we're going to start off with number 26. Number 26, the instructions are asking us to, let me just pull up this textbook here. This says write each inequality using interval notation and then graph each inequality on a real number line. So number 26 is -1 is less than x, less than 5. So in interval notation, what we're going to have is parentheses, -1, comma 5, and then close parentheses. If I'm going to put this on a number line, I'm going to go ahead and put just -1 here. I'm going to go ahead and put 5 there. What's going to happen is there's several ways. Some textbooks do it slightly different. And so if we were doing it just like we write the interval notation, what we're going to do is we're going to put the parentheses on a -1 and a 5, and then sort of connect these into the line, and that's how you would to graph it. Some textbooks, what they do for here is they use the open circle, and so some of them just graph it that way. All right, the next one is number 36. Number 36, it says write each interval as an inequality involving x and graph each inequality on a real number line. And so we're going to go ahead and write it as a inequality. So here, since we have the bracket, is going to be 0 is less than or equal to x, less than 1. And so that's this in interval notation. That's the inequality. And then if we were to graph this, I'm going to go ahead and just put the 0 here and the 1 here. And so in this case, what you do is you put the bracket, open parentheses, and then you're just going to go ahead and connect those two. And that's number 36. For number 56, what they're asking us to do is solve each inequality and express your answer using set notation or interval notation, and then graph the solution set. So here we have x minus 6 is less than 1. What we're going to do is add 6 to both sides, so we get x is less than 7. Now, if I'm writing this in interval notation, it basically is telling me that it's going from 7 to negative infinity, right? So x is less than 7. And so the first thing I'm going to do is I'm going to go ahead and graph it first. I'm going to go ahead and put the 7 there. And so in this case here, it's going to be the parentheses, and then it's going to go down all the way to negative infinity. If I were to do it in interval notation, this is the way that I would write an interval notation. All right, the next one is number 64, and again, we're going to do the same thing. We're going to go ahead and solve the inequality. We're going to write it in set notation, interval notation, and then we're going to go ahead and graph the inequality. If I was writing it, let me go back to this one. If I was writing this in set notation, it would be all numbers x such that x is less than 7. So that's another way that you can write it. So that's interval and set notation. So for number 64, again, we're going to go ahead and solve this. I'm going to go ahead and do the distributive property. So -3 times 1 is -3. -3 times -x is a positive 3x, less than 12. So I'm going to go ahead and add 3 to both sides. So I get 3x is less than 15. I divide both sides by 3, and I get x is less than 5. So if I was graphing this one, I get my 5 here. It's less than, so it's going to be a parenthesis, and then it's just going to go down to negative infinity. In interval notation, that's how we would write that. In set notation, we would just write it the same way that our solution is, and that would be your answer to number 64. So interval notation, this is interval notation here. This is set notation, and of course that's the graph. For number 70, we're going to do the same thing again. Here we have x over 3 is greater than or equal to 2 plus x over 6. And so probably the best thing to do is multiply everything by 6 so we can get rid of the inequality. I mean, of the fraction, sorry. But before I do that, I'm going to go ahead and I am going to subtract the x over 6 from both sides. And I can actually, at this point in time, I can do multiply everything by 6, so I can combine these two. And by doing that, I can just multiply the first fraction by 2. So I get 2 over x is equal to 6. And so I get 2x over 6 minus x over 6 is greater than or equal to 2. So I get 3x over 6 is greater than or equal to 2. I can simplify this to 1/2. So I get 1/2 x is greater than or equal to 2. If I have a coefficient as a fraction as a coefficient, I can just multiply both sides by the reciprocal of that. And so I get x is greater than or equal to 4. So it's so here I got x is greater than or equal to 4. When I write it in interval notation, I'm going to go ahead and put brackets. And since it's greater than 4, it's going to go towards positive infinity. In set notation, it's just going to be x is greater than or equal to 4. And then when I graph it here, it's going to be the bracket going to positive infinity. All right, number 82 is I believe it's the last one in this example. What I'm going to do here is I'm going to move everything to left side. So I'm going to have x times 9x minus 5 minus 3x minus 1 squared is less than or equal to 0. I'm going to go ahead and multiply this out. So it's going to be 9x squared minus 5x. And then here I get the 3x minus 1 times the 3x minus 1. So let's just go ahead and FOIL that. So we get 9x squared minus 3x, right? Here in the middle again, minus 3x, and then plus 1. So it's 9x squared minus 6x plus 1 when we FOIL that. So it becomes a minus 9x squared minus 6x plus 1 is less than or equal to 0. I'm going to go ahead and get rid of this, the parentheses. So my signs inside the parentheses are going to change. So that's a plus 6x minus 1. And so I'm going to combine like terms. So 9x minus 9x, 9x squared minus 9x squared is 0. And then 5x plus 6x is x. So it's x minus 1 is less than or equal to 0. And so at this point in time, I'm going to go ahead and just solve for x. So I get x is less than or equal to 1. And so in interval notation, it's going to look like this. And set notation is going to look like that. And if we were to graph it from the 1, I would have my bracket there, and then it goes over to negative infinity. And that's the end of the examples for 1.